Have a good day to everyone. In this video, we are going to see about pumps and classifications. It is a series of a thing, and it is a part one video. And myself, Mr. Dinesh Kumar, working in Department of Chemical Engineering as an assistant professor, the Department of Chemical Engineering, Hindustan College of Engineering and Technology, Coimbatore. So, what we are going to see is a pump and its classification. So, what is a pump? So, actually, pump is a mechanical device. Okay, so pump is a mechanical device that converts electrical energy into a mechanical energy. But at the same time, due to that mechanical energy is being used to transfer the fluids from one point to another, from one place to another. So usually we use pump to pull the liquid from the bottom to the top side. Okay, transfer of fluids from one place to another. That's it. That is why we are using a pump. Okay, so it is actually functioning by creating a vacuum or pull out the fluid. So that is the classification part we will see in the further slides. And it is a convert mechanical energy into fluid energy. Those things I have already told you about, and how it is being actually considered as impeller or propeller is part of the pump that helps the movement of fluid. Okay, so the main application of pumps is to move fluids. Apart from that, there is nothing. So you need to know that fluids is nothing but liquids and gases. Both liquids and gases will be considered as a fluid. This is the classification of pumps. There are two types of classifications. One is a displacement pumps, another one is a dynamic pumps. So in this slide, we are going to see about what is a displacement pump, what are the types of dynamic pumps. So in the displacement pump itself, there are three different types. Categories have been there. One is a reciprocating one, and another one is a rotary type, and another one is an pneumatic types. Okay. So in the reciprocating pump itself, it is being classified into two, that is piston and a plunger type or a diaphragm pumps. So piston plunger or diaphragm pump type, you just simply can imagine. We are having a video at the end of this slides. So it is nothing but like a injection. How the injection properly works now. That is what an reciprocal piston or plunger type or diaphragm pump. That is how it actually functions. Diaphragm pumps, we can actually say our blood flow in our heart, human heart. So that is what a diaphragm pump likely operates. Okay, so in the section itself, it is being segregated into single, double acting, or a power, simplex, duplex, everything will be segregated. The only thing is, an operation, the principle still stays the same. Only thing is, operation stay difference. Okay, the rotary type pumps have a vane, piston, screw, flexible member, peristaltic is there. So these are all things that kind of a rotation takes place. Still, it looks like a piston or plunger type, but the rotation takes place in this rotary type pumps. Okay, another one is a pneumatic type pumps. So another, there is a multiple rotor also there in rotary type pumps. So these are all the basic classification in the displacement of pumps. In this, when we are entering into the dynamic pumps, there are three things. There are two major categories. One is a centrifugal pump, another one is a vertical pump. So the centrifugal pump is a major chunk plays in our industries. Vertical pump is actually have a role in only a small sector, but plays a huge part. But still, centrifugal pumps is majorly used in everywhere. So centrifugal pumps is being differed based upon their direction of flow, based upon the suction, based upon the mechanical constructions. It is being differed. So radial flow, axial flow, and mixed flow is being done. Okay. So these are all the basic classifications and categories. So what is a positive displacement pumps? So we have already gone through with the positive displacement, what it is, what that it is, and like kind of we have already seen. So this is a positive displacement pump, how it actually works. Okay. So as you see the fluid here, so the fluid is being coming from here. Okay. So sorry, the fluid is coming from here, not coming from here. So the fluid is moving towards here. Okay, so it just creates a vacuum in this place. It just create a vacuum in this place. So due to the vacuum, it pushes the liquid to the left hand side. Okay. So this is what happens in the displacement pump, displacement pumps. Okay. This is where all the categories of pumps actually operates when it comes under the category of displacements. Okay. So what are all the applications when it comes to this is usually in food industries, chemical industries, oil and gas, water treatment plants. So all the industries is being used and advanced advantages. So it maintains a constant flow rate due to continuous vacuum production. The flow rate can be maintained constantly. So its efficiency is very high. As it is as it achieves a constant flow rate and the precise control, self-priming capability, high pressure output. So self-priming capability is the most important one because in some cases priming needs to be done to operate the pump properly. So self-priming capability is there for positive displacement as it creates its own vacuum. So high pressure output, high pressure is very much high compared to other things. So disadvantages is the pulsating flow. Uh, Sometimes it may vary if there is any cavitation is there, the flow will not be constant throughout the operation. And high wear and abrasive fluids. If the fluid is very much density or viscosity, it would affect the efficiency of a motor. And a limited speed range, complex maintenance, overpressure risk, everything is there because its operation, it is since it is provided with a high efficiency, operating continuously, needs to give a constant flow rate. It requires high maintenance. Okay, so and it also overpressure risk. Okay, so these are all some disadvantages. So here we go with the dynamic pumps. So at dynamic pump also we have seen what is the operation, how it operates. We already see. Here we go with the video. How it is actually working. So you can just see the displacement, centrifugal pump, how it is being operated. Okay. So whenever this flange is pushing towards, this ball will move upward. This ball will go downward. So the water will escape from here. So this happens periodically. So the water will continuously or the fluid will continuously move upward. Fluid continuously here moves upwards. So it will be like zigzag. Okay. So this is how this thing operates and application and advantages of these things. So it have high flow rate, simple design and low maintenance, handles wide range of fluids and economical thing compared to with the dynamic one. Okay. So disadvantages, the pressure varies with flow, not self-priming. We needed to prime itself. We needed to prime the thing. Less effective with high velocity, high viscosity fluids, and risk of cavitation is high in this thing because since it is high pressure operator, the risk of cavitation is very much high compared to the displacement pump. So these are all my these are the topic video for the classification of pump. But what are based upon the classification, what are the things that we have seen here? So hope you have understand what is a pump. So still you have if you have some doubts over this thing, so put it on comment or put it on comment. I will try to get back to you and clear your questions. So for thank you for being present to attend this lecture. Thank you.